In this video, we're going to go over the notes for systems of linear equations. This is page 65 on the front, so 65F for your binders. So we've been talking about linear equations. This is our vocabulary, sorry. We've been talking about linear equations, and we know that linear equations look like lines on a graph. They're straight lines. We also know that using letters and numbers, this looks like y equals mx plus b as an equation. That is slope-intercept form because you can see the slope and the y-intercept from the equation alone. This becomes a system of linear equations when you have two or more linear equations. If you will look on page 56 of your binders, you'll see the notes we took for solutions to linear equations. And that was any ordered pair, so x comma y, that was on the line. When you have a system of linear equations, though, you have more than one line. The solution to a system of linear equations would be the ordered pair. The ordered pair, that's x comma y, where the equations intersect. And remember that intersect means to cross. Now there are three types of solutions. The first type is between two parallel lines. These are parallel lines, which means they never ever touch, or they never intersect or cross. If they never intersect, then they do not have a solution. So when you have parallel lines, there is no solution. Another way you can say that is there is zero solutions, zero solutions. So you might see the words no solution or the words zero solutions when you see two parallel lines. The next type of solution is, in 8th grade, it's the most popular type of solution that you're going to see, is when the two lines cross each other at one point. Since they only share that one point, then their intersection is just the one ordered pair. This is one solution. When you have one solution, you are expected to write the ordered pair x comma y. Looking at the last graph, this looks like there's only one equation there. Technically there is. What's happening though is on top of that line is the exact same line, just right on top of it. So right now all you see is my pink pen, but really there's a pink and a black pen right there. When you have the two pens on top of each other like that, if we look at it sideways, they're crossing each other right here, right here, right here. They share this point, they share this point. They share all of the points. So they share all real numbers. That means that there are infinitely many solutions. And that's because it's the same line over and over and over. It's the same equation. Looking at some examples then, we're just going to find the solutions to each of these systems of equations. So we're going to find the solution to the system. I'll call this example 1. Now, I've got a pink line going here. And I'll make the other one a blue line. Now the pink line and the blue line cross each other or intersect right here. So I know that this has one solution. And the solution is this ordered pair. Side to side number line is the x-axis and the up and down number line is the y-axis. I need to write the ordered pair for that solution, x comma y. The x value is -1 and the y value is 1. So the solution is the ordered pair -1, comma 1. Let's call this example number 2. I'll have this be my pink line. And I'll make the other one my blue line. The pink line and the blue line share one point right here. They cross each other just once, which means there's only one solution. And now I need to write the ordered pair of the solution, so x comma y. The x value is -5. The y value of that ordered pair is +4. So the one solution to this system of equations is the ordered pair -5, comma 4. At -5, 4, we have the one solution to this system of equations. Looking at the middle row, I'll have this be my pink line. I'll make this be my blue line, just so I can talk about them easier. Okay, this is example 3. And I can see that the lines intersect right here. Since I can see the one intersection, I know that this is a system of equations with one solution. So I can write that solution as an ordered pair x comma y. The x value is -4. And the y value is 1. So the ordered pair -4, 1 is the solution to the system of equations that's on this graph. It's where the pink line and the blue line intersect. Call this example number 4. Here is the pink line, and then I'll call this one the blue line. Again, I can see the intersection. This is just one solution then, which means I can write the ordered pair to that one solution. The x value, that's the side-to-side number, which is 6. And now I need the y value of that ordered pair, which doesn't go up and it doesn't go down. It's just 0. So the ordered pair 6, 0 is the solution to this system of equations. Now looking at the last two, I'll say this is my pink line, and here's my blue line. I can see the intersection right here. I'm recording a video. I can see the intersection right here, which means there is one solution. Which means I can write the ordered pair so we can tell the location of that solution. The x value of that ordered pair is right here, which is 0. The y value of that ordered pair is -8. This is a special example because the solution is on the y-axis, which means these two lines share the same y-intercept. The y-intercept is the letter b. In this case, b is equal to -8. I just thought that was something interesting for you guys to know. Okay, looking at our last example, I'll call that the pink line, and I'll call this the blue line. Okay. I can see the intersection, so again, that's just one solution. I can write the ordered pair x comma y. Here's the solution. The x value is whatever numbers between 8 and 16. I don't know what these are counting by. These lines are counting by. So I'm going to look for my scale. That would be the number on the very first line. On the very first line, there's not a number. Find the first number, which is 8. 8 is being cut up into 2 spaces, so 8 divided by 2 will tell me how I'm counting. So going side to side, each line is worth 4 because 8 divided by 2 is 4. So this is 4, 8, 12. The x value is 12. Now the y value is whatever number is between 16 and 24. Again, I don't know what that is, so I'm going to look at my scale. My scale on the very first line, there's not a number. Find the very first number going up and down, which is 8. Now again, 8 takes up 2 spots. So to find the scale, we're going to take the 8 and divide it by the 2 slots it takes up. 8 divided by 2 is 4. So I know I'm counting by 4s. Here's the y value. 4, 8, 12, 16, 20. The y value is 20. Close the parentheses. The ordered pair 12, 20 is where those two lines intersect. I want to point out that the blue line has an undefined slope. If you were to write a linear equation, if you were to write an equation for that line, it wouldn't be a linear equation because undefined slopes cannot be linear. You'd have x is equal to a number. That number is 12, so x is always equal to 12. That would be the equation of the blue line. I'm going to split up the notes from today into 2 separate videos because the front page is just identifying the ordered pair, and the second page is actually finding or graphing our own lines and then finding the ordered pair. So that will be the end of this video. If you have questions about this page of notes, please message me on Schoology or drop a comment on this video. And my next video will have the back of this page.